me. This was number 4 on the classwork we did today for 2.3. There was a little bit of concern over how to do this problem, and some of you actually had it just perfect. Others of you, we were factoring out more than we should have. So here's what we're going to do. We need to write this in standard form, so we need to complete the square so we can see the vertex right off. That's what standard form is good for. So I'm going to write this as 2x squared minus 4x and leave a blank, and then write the minus 1. And then I'm going to factor out the coefficient of the x squared. You can't have that coefficient there if you're still going to if you're going to complete the square. So I'm going to factor out that 2, but I'm only going to factor it out from the x squared and the x terms. I'm not going to factor it out from the 1. If I did, then it would actually take more work to make this a perfect square and still keep everything the same. So from here, I'm going to just complete the square inside the parentheses. So I need half of negative 2 squared is 1. Half of negative 2 is negative 1, and 1 squared is 1. And then I need to, because I added something, I need to subtract it back off so it stays the same as what we started with. So what I added is not just 1, I actually added 2 times 1. Because when you distribute that 2 through, we have 1 times 2 is 2. So I added 2, which means I need to now subtract 2. And now I can write this as a perfect square inside the parentheses. So I have 2 times x minus 1 squared. Half of the negative 2 is negative 1. That's how we know what goes here. And then negative 1 minus 2 is negative 3. So this is the standard form of this function. And so the vertex then is just 1, negative 3. And this would be the same answer as we would have gotten on number 3, where we just used the negative b over 2a to find the vertex. So they were the same function, so it definitely should be the same answer. Hopefully this helps. If you have more questions, let me know, and I will see you on